So, good day everyone. In this video, we will be discussing about deferred annuity and perpetuity. When we say deferred annuity, it's simply like the simple ordinary annuity and simple annuity due. The difference with that is for deferred annuity, there is a period which we call period of deferment. Ito yung delay in a way. Unlike sa unlike sa ordinary annuity and annuity due na parang for example for ordinary annuity, for example monthly yung compounding mo and this is the start of your period, 1 month from today, diretso ka na maglalagay ng pera agad sa investment mo. O kaya magbabayad ka na ng investment mo. O magbabayad ka na ng utang mo, ganun. While for annuity due, if today is the start of your period, starting today, magbabayad ka na. For deferred annuity, no? This period of deferment is for example, monthly yung tawag dito, monthly yung compounding periods of your investment o kaya ng utang mo. You'll start paying it off or you start investing money for example after a year muna, ganon. So hindi siya agad-agad na magsa-start yung tawag nito, yung paglalagay mo ng pera for your investment o kaya pagbabayad mo ng pera for your utang. So tawag nito, for example annual yung compounding period mo, tsaka 1 year from today ka magbabayad tapos ordinary annuity siya, it's not a deferred annuity kasi isang buong compounding period naman yung hinintay mo to make your first payment. However, if your compounding period is monthly but you start paying for example 6 months from today or 9 months from today o kaya naman 1 year from today, as long as may parang alam mo yun, it would take you more than one compounding period to start your payment, that becomes a deferred annuity. So let's take for example, let's start with our future value of deferred ordinary annuity. Now, even later on sa future value of deferred annuity due, walang issue kung may deferment man o wala. Okay? So, we ignore the period of deferment for future value na mga problems. So, by saying na we ignore, what do we do ba? We simply use the formula for future value of simple ordinary annuity and future value of simple annuity due. So, whether or not may period of deferment or wala, the formula would be the same. So, let's take for example here. So, find the future value of an annuity of 1,000 payable at the end of each quarter for 6 payments. The interest rate is 6% compounded quarterly. The first payment is due at the end of 9 months. Okay. So, ito, may period of deferment ba? Yes, of course. Kasi yung first payment mo will occur 3 quarters from now And quarterly yung payment mo. So, meaning, nag-skip ka ng 2 quarter. Tsaka ka pa nag-start ng payment mo, which is at the end of the 3rd quarter. So, yung period of deferment natin, So, as you can see here sa formula natin na ito, the period of deferment or D is equal to the length of time before first payment. So, in this case, 9 months. Okay, 9 months. And then, all over the number of days, weeks, months, or years per compounding period. So, ilang months ba yung per compounding period natin? So, since quarterly man siya, there are 3 months per compounding period. So, 9 months divided by 3 months, you have 3 quarters as yung parang period of deferment mo. But we have to deduct 1. Bakit we have to deduct 1? Because this problem is talking about ordinary annuity. So it's talking about ordinary annuity. So if you can recall, if you think of ordinary annuity, Um, like for example, simple ordinary annuity lang siya. You start today, tsaka 3 months after ka pa mag-start ng bayad mo. So if you put it this way, no, na on the ninth month ka nag-start ng payment mo, and this is ordinary annuity, meaning yung pinaka-start talaga ng if we translate it into ordinary annuity, no, yung pinaka-start talaga ng period mo would be on the 6th month, right? So in that case, yung period of deferment mo talaga is only 0 to 6 months. Aray ko, sorry. 0 to 6 months. So 6 months divided by 3 months is actually 2 quarters. So that means your period of deferment is only 2 quarters. So this is what we usually do when it comes to what do you call this one? Ordinary annuity. We deduct 1. So again, the length of time before the first payment over the number of weeks. Kung weekly yung compounding period mo, days, kung daily yung compounding period mo, months, kung monthly yung compounding period mo, o years, kung yearly yung or annually yung compounding period mo, and then you divide that by it, and then you deduct 1. That's when you get your period of deferment. And since, diba, for future value formulas, we ignore the period of deferment, so which means yung formula mo ng future value of ordinary annuity is still applicable herein. So in this case, the formula is the same. Future value of deferred ordinary annuity is still equal to payment times 1 plus I raised to the power of n minus 1 all over I. So in this case, yung payment natin is 1,000. While yung I natin is 6% divided by 4. So that is how much ba? 0.06 over 4. So you have 1.5% per quarter. That is your periodic interest. And then your N or your number of payments. Yung N tsaka yung D had iba yun. Okay? So your N here is simply the number of annuity payments that you will be making. And in this case, usually talaga pag pag deferred annuity payments o kaya deferred annuity problems, ibibigay na sa'yo yung ilan ba yung payments na gagawin mo. So in this case, 6 payments yung binigay, so N mo is 6. And then yung D mo would be your period of deferment, so which is 2. And in this case, again nga, no, we ignore it. So in this case, yung sagot daw is 6299.55. Let's see if we can get the same answer, no? So again, payment 1,000. You multiply that by 1 plus I. So 1 plus I natin is 1 plus 0.06 over 4. And then we raised that to 6 payments, so 6. And then we deduct 1. So enclose lang natin to ng parenthesis. Okay, and then we divide it by 0.06 over 4. Let's see if we get the same answer. Okay, so we actually got the same answer. Okay. So sir, paano naman kung yung binigay sa'yo is yung whole term? So yung whole term ng utang mo, o kaya yung whole term ng investment mo. So for example, no, if we translate this problem into like parang instead of the number of payments yung binigay sa'yo, yung term talaga ng investment mo. So for example, paano ba to? 6 payments, that means ilang quarters? So 6 quarters, so that's 1.5 years. Period of deferment mo is 2, so in 2 years. Okay, so pagpalagay natin na yung no? Okay, pagpalagay natin na same problem ito, but it was stated differently. So, find the future value of an annuity of 1,000 payable on find the future value of an annuity of 1,000 pesos payable at the end of each quarter of each quarter 2 years from now. 2 years from now. So the interest rate is 6% compounded quarterly. The first payment is due at the end of 9 months. So 2 years from now, so yung T mo dito, yung whole term mo is yung whole term mo dito is 2 years, or when we translate it to number of quarters, no? So that's so yung 2 years times ilang quarters ba per year? We have 4. So times 4. So we have 8 quarters all in all. Now, if pag ganito naman yung parang, if this is how the problem is stated, we cannot ignore na the period of deferment. Sir, bakit ba hindi natin siya mai-ignore yung period of deferment? Kasi nga hindi binigay sa yung kung ilang payments ba yung gagawin mo. So since hindi naman binigay sa yung number of payments na gagawin mo, you have to deduct from the total term yung period of deferment. So alam na natin na diba, yung period of deferment natin is again the first payment will occur in 9 months, so 9 months from today. So 9 divided by 3, that's 3 quarters, and then we deduct 1 from it. So yung period of deferment natin is 2. So yung number of payments natin or n will become 6. So that's the term less the period of deferment. So you have your n now, or the number of payments that you will be making. So you have 6. So with that, by using the same information here and the same formula, we will still arrive at the same answer. So for example, 1,000, multiply that by 1 plus 0.06 over 4, and then we raise that to 6, and then minus 1. Again, yung 6 natin is yung n na yun natin na na-solve yun, ha. This is the n that we have solved by deducting from the whole term our period of deferment na 2. So 8 minus 2, we got 6. So yun yung number of payments that you will be making for your investment. We divided that by 0.06 over 4, so we have 6229.55. Okay. Now, let's move on to another example. So, what is the future value of 20 semi-annual payments of 150,000 each made at the end of each 6 months when the first payment is made at the end of 1.5 years if money is worth 10%? So, ilan ba yung how long ba yung time that it took before the first payment was made? So, it's 1.5 years, right? Or this is ilang semi-annuals ba to? So, it's 1.5 years means ilang months ba to? 1.5 times 12. 1.5 times 12. We have 18 months. So, ilang months ba yung compounding period natin? Compounding period or your M. Ay, hindi naman M. Pero sige. Months per compounding period. So, we have ilang months? 6. Kasi nga semi-annual. So, ilang months yung it took? Or ilang semi-annuals it took before the first payment? So, that's 18 divided by 6. And to get our period of deferment, we simply have to deduct from this one, 1. So, 3 minus 1. So, we have 2 semi-annuals as our period of deferment. But then again, it doesn't matter in this case kasi nga, the number of payments that you will be making is already given. So, 20. So, diretso ka na dun sa formula mo. So, ang sagot daw is for, ito daw, magkano ba to? Let's see. 4,959,000. Let's see if we can still get the same answer, no? So, again, 150,000. Again, simply using the formula for future value of ordinary annuity. So, the payment of 150,000. You multiply that by 1 plus our I is 0.10 over 2. Over 2 kasi nga, there are 2 semi-annuals per year. And we raised that by 20. Okay. And then we deduct 1. And then we divide 0.10 over 2 as our I. Then we still got the same answer. So for hindi siya masyadong issue yung period of deferment o kaya yung deferred annuity when it comes to future value problems. Unless na lang talaga yung binigay sa'yo na problem is like this one. Yung retranslated, kumbaga. Tsaka na lang talaga nagmamatter yung period of deferment mo when the problem is all about future value, present value. So in this case naman, no, yung present value mo, parang in this case lang, you actually encounter these type of problems na in our exams during the midterms, no? When we were using equivalent values, because this is kind of like equivalent values lang talaga. So as you can see here, um no, the formula for the present value of deferred ordinary annuity is simply your formula for what do you call this one? Your formula for present value of ordinary annuity, which is payment times 1 less 1 plus I raised to the power of negative n over I, and then multiply ka lang ng 1 plus I raised to the power of negative d, or the period of deferment. So parang ito na yung equivalent value natin na formula actually. So paano ba natin ma-apply yung equivalent value formula na parang in this case na we simply translated present value of ordinary annuity and from its value at a certain point to its equivalent value today. So for example, no, ito. Find the present value of an annuity of 1,000 payable at the end of each quarter for 6 payments. The interest rate is 6% compounded quarterly. The first payment is due at the end of 9 months. Okay. So the first payment is due at the end of 9 months. So again, we have the same formula for the length of time before first payment. So ayun, 9 months yung mag-u-occur yung first payment mo na 1,000, no? So 9 months, just the number of months per compounding period is 3. So that's 9 divided by 3 is 3 quarters, and then we simply deduct 1. So we now have our period of deferment na 2 quarters. Okay? So tawag nito, if we translate it into like parang if we solve muna, kasi nga 'di ba, itong formula na to is simply your present value of ordinary annuity formula. So if you're gonna use this, no, na as our parang point of reference lang muna, so sagot natin would be, for example lang, we're solving for present value of ordinary annuity, not deferred ordinary annuity. So 1,000 yung payment mo, multiply mo yan ng 1 less 1 plus, our I here is 0.06 over 4, and then we raise that to negative n natin is ilang payments daw? So 6, negative 6. And then we divide this one by our I, which is 0.06 over 4. So, over 4. So, we got 5697.19. So, home. Saan ba yan? Okay. So, meaning, kasi nga, diba, if you can recall what I have mentioned or what I have said kanina, na for ordinary annuity, since, for example, in this problem, 9 months, since on the 9th month yung start ng payment mo, so meaning yung start ng period mo talaga is on the 6th month. Right? So meaning, ito yung value mo, ito yung value ng utang mo, o kaya nung annuity payments mo, 6 months from today. So magkano ba yung equivalent value niya today? So now, by applying our what do you call this one, our knowledge on equivalent values, we now know na to bring it back from 6 months to today, we use the equivalent value formula by using the compound amount formula. So in this case, to ilang quarters ba yung 6 months from today? So that's 2 quarters, which is our period of deferment. So to bring the 5697.19 to its equivalent value today, so we simply have to multiply this amount by 1 plus our I is 0.06 over 4, and then we raise that to our ilang quarters natin siya ibabalik? 2 quarters, so negative 2. So you will get 5530.04. So paano ba yun, sir, if we simply tawag nito, isahang calculate lang, isahang calculation lang sa calculator na hindi ka na pupunta pa sa present value of ordinary annuity. So, paano ba yun? So, our payment is 1,000 and then we multiply that by 1 less 1 plus I, so 0.06 over 4. And then we raise this one to ilang payments yun? 6. And then we divide this whole expression. Tama ba? We divide this whole expression by 0.06 over 4, which is our I. And after that, we multiply that by 1 plus I, so 0.06 over 4. And then we raise it to our negative D of negative 2. So, ayun, you will still get the same amount. So, yun lang yung kaibahan ng deferred annuity. Doon lang siya talaga nag-a-apply sa present value calculation. Unless na nga lang talaga yung problem na binigay sa'yo for future value problems would be stated like this, no? Na yung term yung binigay sa'yo, hindi yung number of payments na gagawin mo. So, ayun. What else ba? So, we're done with that. So, let's take, for example, let's take another example, no? So, if 40,000 quarterly payments were made at the end of 3 years for 10 times. So, if quarterly payments were made at the end of 3 years for 10 times, what is the value if today if the interest rate is 12%? So, ito yung problem na to. Parang, starting 3 years from today, magbabayad ka ng 40 quarterly payments ng 10 beses. So, yung yung length of time no na it took for you to make the first payment is 12 ilang so 3 years. So 3 years is 3 times 4, so that's 12 quarters. So yung D mo is simply the 12 quarters, you deduct 1 from it. So alam mo natin yung period of deferment natin. So our payment is 40,000. Yung number of payments natin is 10. And then our I is 0.12 over 4. So that's 0.12 over 4. That's 3% per period or per quarter. And then our period of deferment is 11. So if we solve it, no, ito dapat yung sagot natin. So ito. So payment natin is 40,000 and then you multiply that by 1 less 1 plus I, so 0.03. We raise that to ilang payments daw yun? 10 payments. And then we divide this one by 0.03. And then we multiply this by 1 plus 0.03. We raise that to our negative D or negative 11. So we still got the same answer. So pag na-master mo na talaga yung pag na-master mo na talaga yung equivalent values, na-master mo na yung annuity, yung simple annuity formulas or simple ordinary annuity tsaka simple annuity due, madali na lang sa'yo i-solve din yung what do you call this one? Madali na lang din i-solve yung deferred annuity problems. So for this one guys, no, for future value na formulas, even applicable din sa future value of deferred annuity due, yung formulas mo for payment, tsaka yung formulas mo for I, tsaka yung N, so yung payment, no, simply divide mo lang to dito. So FDOA divided by this table factor. This is what we call the table factor, no, the 1 plus I raised to the power of N minus 1 over I. O simply yung formula mo na sa ordinary annuity na for payments, for I tsaka N is still applicable for future value of deferred ordinary annuity. So, however, mag-iiba na yung formula mo for present value of deferred ordinary annuity. So, ano na ba yung formula mo kung sa payment yung wala o kaya si N yung wala o kaya si I yung wala? So for example, no, what's your formula kung si payment yung wala? So ito yung original formula natin na payment times 1 less 1 plus I raised to the power of negative N over I times 1 plus I raised to the power of negative D. So what's your formula na if payment is unknown? So simply yung ano, 'di ba? This one, paano ba siya, sir, paano ba, ano ba nangyari? Ba't itong negative D mo naging numerator na dito? So, again, no, if you can recall na yung negative D mo, na pag yung exponent mo is negative, pwede mo siyang i-express as 1 over, so parang ito yung, let me just, ano na lang, let me just move my face here. Show it by showing you the entire showing you the entire formula na lang instead. Do I have the formula here? Ay, wala. Hindi ko siya na-translate dito. Okay. So, ito. So, uh, ulit, ulit. Okay. So, ayan. So, PV of DOA, Deferred Ordinary Annuity, is equal to payment multiplied by, so lagay tayo ng fraction, 1 less script 1 plus I raised to the power of negative n over I, and then we multiply this by 1. Okay. Equation. Okay. So this is 1 plus I raised to the power of negative D. So this formula actually, guys, can be expressed also as this one. So same na lahat yan. Pero ito, pwede mo siyang gawing ganito. I'm sorry. Ito na lang. 1 over. Let me copy this one. Okay. Okay. So yung negative D mo, pwede mo siyang i-express as ganito, yung formula mo. Kaya sa paglilipat mo, no, paglilipat mo ng ng formula na to into payment, o kaya pagta-transform mo ng formula into a formula for payment when payment is unknown. So yung PV DOA mo would remain at the numerator. Yung I mo na nasa denominator, malilipat siya sa taas. So, times I. Yung 1 plus I raised to the power of D mo na nasa baba, malilipat din siya sa taas. So, cross-multiply nga. So, times 1 plus I raised to the power of D. All over, yung numerator mo dito, no, na 1 less tsaka times 1. So, pwede mo nang i-ignore yung times 1. Ito na lang yung matitira. So, siya yung magiging denominator mo. Ito. So, 1 less 1 plus I raised to the power of negative n. Kaya yun yung parang rationale kung bakit ganito yung formula natin. So, formula for payment would be PVDOA times I times 1 plus I raised to the power of D all over 1 less 1 plus I raised to the power of negative m. So, pagpalagay natin, no, na we have this example. So, our PVDOA is this amount. Yung entire talaga yung kinuha natin, no, para we will arrive at the same parang payment without fraction or kaya without decimal points. So alam natin na, so for example, no, paano ba siya how do we state it ba in like in a problem? Sige, pagpalagay natin na ito. The value of an annuity payment, of a deferred annuity payment today is 246,496. Okay. Okay. So if the first quarterly payment is made at the end of 3 years for 10 times, how much is the quarterly payments if the interest rate is 12%? So, ito, no, given sa atin yung present value natin na 246,496,00, and then, yung N natin, alam natin na 10 times yung gagawin na payment. Yung I natin, alam natin na 12%. Move ko lang yung mukha ko. 12% divided by 4, or again, 0.03. So, 0.12/4. So, 0.03. Tsaka yung D natin, alam natin ng 11 kasi nga, di ba, this is, ilang years nga yun? 3 years. 3 years yun, di ba? 3 years, multiply natin ng 12 months per year, divide natin ng quarterly payments eh. So, 3 months. Divide natin ng 3, minus natin ng 1. So, we have 11 as our period of deferment. So, using our formula here, so try natin isolve if we will get 40,000. So, payment natin is, yung what do you call this one? Our present value of deferred ordinary annuity is 246,496, and then we multiply that by our I is 0.03, then we multiply that by 1 plus 0.03, which we raise to the power of D, 11. So, hindi siya naka-negative, ha? Take note. Divided by 1 less 1 plus 0.03. We raise that to the power of our negative N. So, that's negative 10. So, try natin if we will get 40,000. Okay. So, pag ni-round off mo yan, you will get 40,000. So, ayan. So, paano naman kung N yung unknown? So, kung N naman yung unknown, no? So, given our formula na ito, so, baka makalimutan ko, gawin ko munang pictures to. Kasi nawawala to pag ina-upload na siyang file. Tsaka ito din. Okay. So again, no? Ito yung buong formula ng PVDOA. Tsaka so when we transfer kumbaga lahat ng other items o kaya expressions of the formula to the other side para yung matira is yung N natin on one side, no? So PVDOA will remain at the numerator, yung I will become a numerator, yung 1 plus I raised to the power of negative D is expressed as 1 over 1 plus I raised to the power of positive D, kaya siya naging, so denominator siya dito, naging numerator siya paglipat mo. Tapos, all over payment. Okay? So, in this case naman, since we want to solve for N, so, lipat lang natin yung negative na 1 plus I raised to the power of negative N to the other side, tsaka yung positive na ito, lipat natin to the other side. So, that's why this happened. And then, again, since negative N to, and we want N to be expressed as a positive number, so we transform this into 1 over 1 plus I raised to the power of N. So, to transform N, to transform the formula in a way so that our N is on the numerator side. So, we cross-multiply this one. So, 1 plus I raised to the power of N. Tsaka yung buong expression na to will become our denominator on the other side. So, N here is equal to log of this whole expression all over log of the base here na 1 plus I. So, yung PVDOA natin, again, 246,496. N natin, which is, hindi pa natin alam to. Um, we don't know it yet. This is the unknown nga. So, yung I natin is 0.03. Alam mo natin na 11 yung period of deferment, tsaka yung payment natin is 40,000. So, by using this formula, so let's try to solve for to solve for n here. So log of yung log natin is 1 over 1 minus PVDOA. So 246,496, right? Multiply natin ng 0.01, 0.03 pala. Multiply natin yan ng 1 plus 0.03. Raise to the power of positive d, which is 11. Okay. And then, okay. Divide natin ng payment ng 40,000. Okay, so na-close na yung buong expression. Okay. Okay, and then, yung base natin is 1 plus I. So, that's 1. Sorry. Wait lang. So, 1 plus 0.03. So, let's hope the 10 yung lalabas. Okay, so 10. So, tama. So, tama yung formula natin. Kasi nga, diba, based on this problem, 10 nga yung number of payments na gagawin mo. So, paano naman kung yung unknown mo naman is I? So, kung I naman yung unknown mo, interpolation as usual. So, in this case, no, asan ba yung I natin? Okay, interpolation. Asan ba yun? Asan na nga ako? Okay, yun. So, this is our parang basis formula, no? And then, asan na ako? Okay, so, ito yung given, PVDOA, yung present value mo is 246,496, N is 10, unknown si I, si D is 11, payment is 40,000. So, if parang hindi to yung sige, let me retranslate this problem into something that we can ito ba yun? Hindi, 12.4% to eh. Change ko lang. Okay. So, start muna tayo dito sa tawag nito. Start muna tayo dito sa una na problem, yung which is alam natin na 12% yung alam natin na 12% yung natin, yung I. Pero chine-check lang natin kung what do you call this one? Chine-check lang natin kung 12% ba talaga yung I na unknown. So, malamang yun yung lalabas. So, again, for interpolation, trial and error. Hindi naman importante kung anong percentage ka magsa-start. But again, usually, I will start at 10%. So, at 10%, no, magkano kaya yung present value of deferred ordinary annuity. So, alam natin na yung payment natin is 40,000 and then we multiply that by 1 less 1 plus hindi pa natin, so 0.10, so 1 plus 0.10 over 4, and then we raise that to ilang payments nga yun? Negative 10. Okay. And we divide it by our I of 0.10 over 4. Okay. And then we multiply that by 1 plus I, so 1 plus 1.10 over 4. We raise that to our negative D or negative 11. So, 266 daw. So, hindi ito yung amount na hinahanap natin. So since we want to go lower, no? We want to go lower dun sa amount na kasi yung target amount natin is 246,496 eh. So, since we need to go lower sa present value, we have to make our interest na ginamit higher. So, we will try 11%. So, 0.11, 0.11, tsaka 0.11. So, 256,435, hindi pa din siya. So, try natin yung try natin yung 0.12. So, 0.12. 0.12, and then here, 0.12. So, ayun, lumabas na. So, meaning, yung interest rate na applicable for this problem is 246,496. But let's try a problem na hindi buong percentage yung unknown. So, sige, let me retranslate this problem, no? So, if the present value of a deferred ordinary annuity, the present, not, hindi mo na mag-if. So, the present value of a deferred ordinary annuity is magkano daw? So, try natin po. Magkano ba ito? Okay. Deferred ordinary annuity is 242,638.89. If you make 40,000 quarterly payments, if you make at the end, starting at the end of 3 years from today, for 10 times, the present value of a deferred, if you make 40 payments starting at the end of 3 years from today for 10 times, what is the interest rate? Of this annuity payments? What is the interest rate? What is the interest rate applied to this annuity? So, alam natin na yung present value natin is 242,638.89. Yung N natin is HBB. Okay. Ito, erase na lang natin yung iba muna. 89. Okay. Alam natin na yung number of payments na gagawin natin is 10 times. Hindi natin alam kung magkano yung interest rate na yung nominal interest rate na charge for this problem. Alam natin na yung D natin is 11 kasi nga 3 years times 3 years times ilang quarter ba every year? So 3 years times 4, that's 12 quarters, and then you deduct 1. Kasi nga, yung buong length ng time before you make your first payment, and then you deduct 1. So that's 12 minus 1, 11. Payment natin is 40,000. So, let's try, tawag nito. So, given sa taas, no? Given sa taas na problem, since similar lang silang dalawa, difference lang nila is that 242,638.89 yung target na natin na PV DOA, or present value of deferred ordinary annuity. So, we no longer need to start over doon sa we no longer have to start over sa point 10, which is usually doon ako nagsa-start. Pwede ka namang mag-start diretso ng 12. So since dito no, alam na natin na yung 12 sa 12% pa lang, alam na natin na 246,496 na yung present value niya. And yung target natin is lower than that. So let's try 13%. So let's try 13%. So 13, saka 13 dito. So, 236,976, mas mababa naman to sa target natin. So, alam na natin na ito yung high, tsaka ito yung low natin, no? So, again, there are two ways in solving for interpolation nga, diba? You can use yung high yung constant mo, o kaya yung low yung constant mo. So, let's try here muna, yung high ko yung constant natin. So, pag high constant natin, So, high minus x. So, high minus x. So, ito. And then, pag ano naman, kung sa baba, high minus low. So, high minus low. On the other hand naman, we can do it na parang si low yung constant natin. So, x minus low. Sa baba naman, high minus low pa din. Okay. So, again, it's high over low. So, parang ito, high minus x over high minus low or x minus low over high minus low. So, difference, quotient ng mga numbers na ito. So, divide mo lang itong dalawang number na to, kaya ito. So, in this case, no, yung constant natin is yung high. So, yung constant natin is high. So, meaning mag-start tayo ng 12. And since we need to go, parang our target amount is in between 12% and 13%, the 0.40 will be added to 12. So, 12 plus this one is 12.40. And on the other hand naman, no, since our constant here is low, so yung starting point natin would be 13%. And to have a number in between sa 12 tsaka sa 13, so meaning we have to deduct this amount or this number from 13. Kaya 13 minus this one, we will still have the same na parang percentage as our starting point. So pag ni-round off mo to, no, 12.41 to eh. So, try natin yung 12.41. Kung magkano yung 12.41. 12.41. So, 242,546. So, medyo mababa na siya kumpara dun sa target natin. Difference niya from our target is magkano ba? Less. So, 95.58 pesos. So, let's try to check yung 12.40. Try natin yung 12.40 kung mas malapit ba siya doon sa target natin. So, try natin yung 12.40. 12.40. Kasi nga, di ba, yung 12.41 is mababa sa target. So, we need to go higher doon sa percent value na kukunin natin. That's why we need to lower down our our nominal rate na ginamit. So pag ginamit mo yung 12.40, difference niya is 0 actually. So meaning yung actual talaga na interest rate for this problem is 12.40%. So that's it for our deferred ordinary annuity. Now let's go to our deferred annuity due. Okay. For deferred annuity due, again, we also ignore here, especially pag binigay na sa'yo yung number of payments. But pag hindi naman binigay yung number of payments sa'yo, no? Sige, try natin pag hindi binigay yung number of payments naman. Okay. So, again, pag binigay na sa'yo yung number of payments, ignore mo na yung D. Ignore mo na yung D mo. But how do we solve for D ba? For annuity due na mga problems. So, yung D natin sa annuity due problems, hindi ka na magdideduct ng 1. Kasi nga, for example, ito. What is the future value of 20 semi-annual payments of 150,000 each made at the beginning of each 6 months when the first payment is made at the lapse of 1.5 years? So, meaning, yung first payment mo is start ka ng 1.5 years from today. So, ayun. So, 1.5 years, ilang ano ba yun? Ilang semi-annuals ba yun? So, yung semi-annual mo, 3. Diba? So, 3. So, 3. So, so this is your 1.5 year. This is your 1 year. This is your 6 months. And this is your 0. So this is since ito is annuity due. So kung kailan ka nagbayad ng unang payment nung unang payment mo, yun din yung start ng mo. Yun din yung start ng what do you call this one? Start ng term mo, kumbaga, if you're dealing with annuity due problems, 'di ba? So, beginning yung start ng payment mo, hindi ka na babalik ng isang period pa, unlike sa ordinary annuity, kasi nga, yun Yun yung essence ng ordinary annuity eh. So yung first payment mo is like parang 1 quarter ahead of the actual start ng period. Kaya nag-deduct pa tayo ng 1. However, for annuity due, iba yung sitwasyon. For annuity due naman, kung kailan yung start ng payment mo, yun din yung start ng period mo for annuity due problems. Yung simple annuity due problems ha. So meaning, yung tawag nito, yung buong period of deferment mo talaga, pag nag-compute ka ng o kaya yung parang if we look at it at the lens of parang or at the perspective of an annuity due problem, yung start talaga ng term ng utang o kaya ng investment mo is on the 1.5 or like 1.5 years from today. So, meaning, yung period of deferment mo is yung buong 1.5 years o kaya 3 semi-annuals. So, walang deduct 1. Walang minus 1 dito sa Walang minus 1 dito pag annuity due na siya. So, in this case, but again, since we will ignore, di ba? We will ignore naman talaga yung period of deferment pag sa annuity due problem. So, wala tayong issue doon. Since we will ignore naman, no? So, yung payment natin dito is 150,000. Yung I natin is 0.10/2 kasi nga semi-annual o kaya, magkano ba to? 0.5. So, N natin is 20 payments. Tsaka yung D natin, which we will ignore naman din, is 3. So, try natin solve using the formula ng annuity due na simple. Kasi nga, it's still the same formula that is applicable. So, payment natin is, magkano ba yung payment natin? 150,000. Multiply natin yan ng 1 plus I raised to the power of N. So, 1 plus I, plus our I is 0.05. We raised that to, ilang payments to? 20. And then we deduct 1. And then, yeah. So, dagdagan pa pala natin ito ng isang. Okay. We deduct 1. And then, we divide it by our I of 0.05. Then, we multiply it by 1 plus I. So, 1 plus 0.05. Okay. So, yung future value natin is 5,207,887.77. So, so if we translate this into a parang hindi ganto, hindi binigay sa iyo yung hindi binigay sa iyo yung what do you call, ilang payments yung gagawin mo. So, tingnan natin kung ilang terms lahat-lahat to. So, 20 semi-annual payments, ilang taon ba yon? So, that's 10 years. So, what is the future value of 150,000 semi-annual payments? Sige ha. 150,000 semi-annual payments, each made at the beginning of each 6 months, 11.5 years. 11.5 years from today. Okay, so 11.5 years from today, when the first payment is made at the lapse of 1.5 years. So, tingnan natin na. So, 1.5 years siya na. Wait lang. Imaginean ko muna, guys. 1.5, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11. So, 11 years lang siya. Ay, oo nga. So, tama na 11.5 years from today. Okay. Yes, okay. So, ayan. If money is worth 10%. Okay. So, ilan ba yung, magkano ba, ano ba yung T natin dito? Yung buong term ng investment na to. So, 11.5 years is ilang, ano ba to? 11.5 times 2. So, 23 semi-annuals yung mangyayari or yung buong content ng problem. Tsaka yung D mo dito, alam mo na yung D mo is 3. So, meaning, yung N mo, yung number of payments mo dito would be 23 minus 3. So, 20 semi-annual payments. So, payment mo, same pa din. Ito pa din lahat. So, copyahin lang natin to. So, copyahin lang natin to. Kasi same lang naman din yung data. So, solve na tayo ng present value, future value of annuity due. So, that's 150,000. Multiply mo yan ng 1 plus 0.05 raised mo to 20 payments kasi yun yung na-solve natin, excuse me. And then, we deduct 1 and then we divide. Dagdagan mo nga ng isa pa. Sorry. Divide mo siya ng 0.05 and then you multiply it by 1 plus 0.05 raised mo. Hindi ka na mag-raise. Ayun. So, we still got the same answer. Okay. So, paano naman kung present value na of again, so for this guys, for the future value of deferred annuity due, if si payment yung unknown, si I yung unknown, o kaya si N naman yung unknown, you will still use the formulas for payment I and N sa formulas ni simple annuity due problems. So you can still use those formulas. So let's go now to the present value of deferred annuity due. So for the present value of deferred annuity due, actually guys, hindi na siya bago for us. Hindi na siya magiging bago because we have discussed this now when we discussed that present value of deferred ordinary annuity. Sir, iba naman na yung formula niya. So let's see, tingnan natin ha. Okay. So yung present value of deferred annuity due is equal to pay. So yung formula mo for your present value of simple annuity dues, which is payment times 1 less 1 plus I raised to the power of negative N over I times 1 plus I. And then by simply, parang alam mo yun, equivalent value pa din. So, multiply mo lang yan ng 1 plus I raised to the power of negative D. And then, since, diba, for kung napansin nyo, when we computed for D, pag annuity due, is hindi na natin parang hindi na tayo nagdideduct ng 1 dun sa D natin, if you can recall in this problem, no? We hindi na tayo nagdideduct ng 1 kasi nga, 'di ba, the occurrence of the first payment is actually the start of the period when it comes to annuity due problem. Right? So unlike dun sa ordinary annuity, na we still had to deduct 1 kasi nga the first payment simply indicates that the start of the period is 1. As the start of the entire parang compounding period actually is 1 compounding period before the first payment. Kaya we deduct 1 from that 1. But for annuity due, we no longer had to because the start of the first payment actually indicates the start of the period. So, no longer had to deduct 1. So, in this case naman, no, so yung D natin, hindi na tayo deduct ng 1. But, remember guys, that when you are multiplying same terms, and they have exponents, you can add their exponents. So, in this case, no, 1 plus I, may exponent to na 1, tsaka 1 plus I yung exponent ng negative D. So, in this case, 1 plus I raised to the power of 1 minus D. So, yung D for annuity due ha, yung buong deferment talaga, hindi ka nag-deduct ng 1 dun eh. But since nga, this formula is an annuity due formula, may 1 plus I raised to the power of 1 siya. So, pag kinumbine mo na itong dalawang expression na to, magiging 1 minus D siya. So, parang yung formula mo talaga dito is like, similar lang doon sa deferred ordinary annuity. So, ito, 1 minus D nga siya, dito yung nakalagay sa formula. Pero yung D mo naman dun sa deferred ordinary annuity mo, nag-deduct ka na ng 1. So for example ha, pagpalagay natin na yung D mo dito is 3. So yung D mo dito is 3. Kung ordinary annuity, kung deferred ordinary annuity mo dito mo for the yung deferment period of deferment mo for deferred ordinary annuity would be only 2 kasi nga 3 minus 1. But pag dito naman sa deferred annuity due, magiging 2 lang din siya. Paano? So kasi nga, 'di ba, kung yung D mo dito is 3 and you no longer had to deduct 1 kasi nga annuity due siya. So 3 yung ilalagay mo dito sa formula mo, 1 minus 3 is still negative 2. So same lang din yung concept niya. Okay. So paano siya i-apply dun sa form sa natin, no? Paano siya i-apply dun sa pag may problem na siya? Okay. So if 40,000, asan ba 'yun? Okay. So if 40,000 quarterly payments were made at a lapse of 3 years for 10 times every beginning of the period, what is its value today if the interest rate is 12%? So D natin, again, we don't have to deduct 1 from it. Okay, so ayun. 3 years times 4 quarters per year, we have 12 years to 12 years. 12 quarters as our period of deferment. So alam na natin na 40,000 yung quarterly payments and you have to make 10 quarterly payments. Tapos yung I mo dito is 12% divided by 4. So, 0.12 over 4. Sorry. So, you have 3%. So, yung period of deferment mo nga is 12. So, try natin i-solve using this formula. So, payment mo is 40,000. Okay, multiply mo yan ng 1 less 1 plus I natin dito. 1 plus I is 1 plus 0.03. We raised that to what? N. So negative N. So that's negative 10. And then we divide this one by I. So 0.03. Okay. And then we multiply that by 1 plus I is 0.03. We raised that to 1 minus 12. Kasi 12 natin yung period of deferment natin is 12. So, 1 minus 12. So, actually, guys, if you recall, no? So, ayun. If we compare it, kasi same problem to dito sa sa ginamit natin same problem to sa ginamit natin for for ordinary annuity. So, asan ba yun? Hindi yan. What happened here? Okay. Not that one. Ito. So, diba, parang it's still the same problem. The only difference is that, yun lang na, you're making your payments at the beginning of each period. Yung sa kabila, ito, you're making the payments at the end of each period. In this case, you're making the payment at the beginning of each period. So in this case, kahit na yung problem would be annuity due or kaya naman ordinary annuity, same pa rin yung result mo. I'm sorry. You just simply have to remember, no, na pwedeng yung remember mo na lang is yung formula for present value of deferred ordinary annuity. Just make sure that your D always deduct 1 from it. Para hindi mag-iba yung result mo. Kasi pag hindi ka nag-deduct ng 1, then ibang usapan na 'yon. Okay? So same pa rin yung sagot. So ayun. For payment naman, since what do you call this one? Since similar naman din yung formula in a way kasi nga yung ito negative dito. if you notice lang siguro no, the difference is that in this for kung si payment yung unknown, 'di ba yung formula natin for yung formula natin um ordinary annuity is nasa taas yung 1 plus I, 'di ba? Nasa taas yung 1 plus I ng uh what do you call this one? 1 plus I raised to the power of D. So, in this case naman, guys, pwede naman din na nasa taas to. So, paano ba siya gagawin na nasa taas yung formula? So, pagpalagay natin na ito siya. Okay. So, ito, pagpalagay natin na ito yung formula natin. And then, instead of 1 minus D, we can express it as negative negative D plus 1. Okay, so negative D plus 1. Okay, negative D minus 1. Ganun. It will still be the same. 'Di ba? Kasi pag minultiply mo yung negative na yan na sign doon, is negative D plus 1. Okay, so pag yan yung formula natin, so pwede mo siyang i-express as ganito. Payment, okay. Equation, fraction. So, 1 over sa pini. Sige, ito na lang. Equation. Okay. So, 1 plus I raised to the power of D minus 1. Kasi you have to eliminate kasi nga, naka-negative siya. So, since naka-negative man siya, sorry. Ano to? Hindi ka man ma-erase. Sorry, asan na yun? Equation, fraction. 1 over 1 plus I raised to the... Equation. Scripts. Ayun. So, 1 plus I raised to the power of D minus 1. So, pag ganito na siya, pag ganito na yung formula mo, pag transform mo na yan lahat, no, then, payment here will be equal to, so, hindi, equation. So, PVD, scripts. PVDAD, okay, multiply natin ng I, kasi nga nasa denominator si I, diba? Tapos multiply natin to ng 1 plus I, sorry. 1 plus I raised to the power of D minus 1 all over 1 less 1 plus I raised to the power of negative n. Okay. So, kopya ko lang muna ito. HBS, JPEG. Kasi, okay. So, if you can notice, no, this formula is quite similar na dun sa formula mo for payment using if ordinary annuity yung problem mo, no? So, try natin. Okay, try natin. So, so for example, yung PVDAD natin is 246496 as we have solved in this problem din sa taas, no? Tapos yung N natin is 10, we know na yung 10, and then yung I natin is 0.12 over 4. So, that's 3% per quarter. And then, yung D natin is 12. So, if, no, gamitin muna natin tong formula na ito, yung formula na first. So, PVDAD is 246. Sorry. 246,496. We multiply that by our I, so 0.3. We divide that by 1. Sorry. Hindi pala ako naka-equal sign. Okay, 1 less 1 plus 0.03. We raise that to how much? Negative n. Negative n natin is negative 10. Okay, and then we multiply this by 1 plus 0.03. And then we raise that to 1 our D here, since annuity due nga hita yung deduct doon ng 1, diba? Pero may 1 minus 12. Okay. Okay. So we arrive at this one. 40,000. Now, let's try naman itong similar doon sa Let's try naman itong formula na similar doon kay similar doon kay present value of deferred ordinary annuity. So PV equals PVDAD daw, so 246,496. We multiply it by our I na 0.03. And then we multiply this by 1 plus 0.03, our I raised to the power of D minus 1. So that's 12 minus 1. Okay. And then all over 1 less 1 plus 0.03. We raised that to the power of negative 10. Negative n kasi, diba? Okay. So, we still got 40,000. So, ganun ka-versatile talaga yung mathematics, guys, no? Kahit na anong forma ng formula mo, it's okay as long as you arrive at the same answer. So, ato naman, paano naman kaya kung tawag nito, si n yung unknown. So, this is one formula that you can use, no? Asan ba yun? Okay. So, this is one formula that you may use, but you may also use this formula. Insert. Symbols equation. Nakopy ko na ba yun sa taas? Yes, okay. So, you may also use this formula. N is equal to hindi. Equation. So, ito na lang. So, pwede din ito. So, log of fraction tayo. Sorry. Log of 1 over 1 less bracket. So, ito. PV, subscript muna tayo. PV, TAT, sorry. Times I, times 1, equation scripts, exponents. 1 plus I raised to the power of D minus 1 over payment. Okay. All over log of 1 plus I. So, pwedeng ito yung formula na gamitin nyo. Pwede din ito. So, itong formula na to naman, no? Capital HB. Yes, if you can see, this is quite similar to the formula here. Dun sa DOA naman natin, the Deferred Ordinary Annuity. So, any formula na gagamitin mo, you will still arrive at the same answer. So, let's see. So, unang gamitin muna natin yung unang formula na to. So, log of. So, yung number natin is 1 over 1 minus PV80. So, that's 246, 496. Multiply din natin ng I. Our I here is 0.03, diba? And then, we divide this by payment natin here is 40,000. And then, we multiply that by 1 plus 0.03. We raise that to 1 minus 12, our D. Yes, and then our base here is 1 plus I, 1 plus 0.03. So, we arrive at 10. Now, let's try naman using this formula. So, using this formula naman, no? So, we have log of, number natin is 1 over 1 less. Payment natin here is, PV natin is 246, 496. And then we multiply this by 0.03. And we multiply this by 1 plus I. 0.03 raised to the power of D minus 1, 12 minus 1. And then we divide the entire thing by our payment of 40,000. Okay. And then our base here is 1 plus I. 1 plus 0.03. And we will still arrive at 10. Okay. So again, whichever formula you will use, you will still arrive at the same answer. For ano naman, no? For N, so for I, if your interest rate is the unknown, so again, this is our base formula, no? Asan ba yung base formula natin dito? Eto, ay, hindi to. So, for our formula, no? Again, it's next to the power of 1 minus D. So, this is our formula here. Okay, and then through trial and error, we will try to solve for the present value, and we start at 10%. So let's try 10% here. We have we know that our payment is 40,000, so 40,000. We multiply that by 1 less 1 plus. Again, let's try to start at 10%. Again, there is no exact rule that you have to start at 10%, ha? It's your own discretion. You may start at 15%, you may start at 5%, whichever percentage you like. Okay, and usually I usually go for 10%. So, over 4, we raised that to negative n. So that's negative. Our n here is 10 payments, so 10. And then, which we divide all of this by I. So 0.10 over 4. And we multiply this one by 1 plus I. So 0.10 over 4. And we raise that to 1 minus 12. 12 is our D here. So 266, it's higher than our target of 246496. So since it's higher, we have to go for a lower present value, thus needing us to increase our interest rate used. So from 0.10, we go for 0.11. Where am I? Okay, I'm sorry. 4.11, and then here 0.11, 0.11. So we have 256 is still not is still far no from our target amount of 246496. Now we go to 0.12. 0.12, 0.12, and then 0.12. And we got our our PVDAD, which means that the interest rate relevant to this problem is 12%. So we're done na with our deferred annuity problems. Now we go to perpetuity. Perpetuity, guys, actually is very simple. So very simple. When we say perpetuity, guys, no, it's eternal, forever, ganon. So if you can recall, guys, if you can recall your simple interest formula, so interest is equal to principal times rate times time. But in this case kasi, guys, no, for perpetuity, time is no longer essential. Why is it not essential? Because time is infinite na, is no longer limited. So since time is no longer essential, we remove t from the formula. That's why we have here our basic equation of I, or interest, is equal to principal times rate. And this can be interpreted for perpetuity, ha. I here is our perpetuity payments, P here is our present value, and R here is our rate. Sir, is there a problem concerning future value when it comes to perpetuity? There is none. When we're talking about perpetuity, we are only concerned of present value. Okay? So, ang sarili siya ang, sir, ano ba yung, parang example ng mga perpetuity problems. So, yung mga problems na to, parang their concern is you put up money today, and then every time na mag-i-interest siya, i-withdraw mo yung interest. Hindi mo babawasan yung principal, kukunin mo lang yung interest. So, pagpalagay mo, may pera kang 1,000. Tapos, every year, manganganak siya ng 10%. So, every year, may magkano yung 10% mo. That's 100, right? So, 1,000 times 0.10. So, that's 100. So, kung compounding yon, di ba? By next year, yung 1,000 mo, yung interest mo, more than 100 na, because kung compounding yun, yung gagawin mo, 1,000. Plus the 100 na interest mo for 1 year, that's 1,100. Yung interest mo, pagka next year, would be 1,100 times 10% would be 110 pesos. Yun yung thought ng compounding. Pero yung thought kasi ng perpetuity is that every time na manganganak yung pera mo, kukunin mo yung anak. So, 1,000 times, multiply mo ng 10%, 100. So, may 1,100 ka after 1 year. Pero, i-withdraw mo yung 100. So, yung matitira sa'yo, 1,000 na naman ulit. So, by next year, yung interest na ma-earn mo is still 100 pa din. Ikukunin mo ulit yung 100. By third year, yung interest na ma-earn mo, still 100. So, yun yung perpetuity. Na every time na manganganak ng interest yung principal mo, kukunin mo. Yun yung annuity payments mo, kumbaga. So, yung perpetuity problems is parang ganito. Magkano yung tatabi mong pera ngayon para magkaroon ka ng withdrawals every period na gantong amount. So, yun yung concept ng perpetuity. So, for example, ito. Find the present value of a simple perpetuity of simple ordinary perpetuity to simple ordinary perpetuity. Find the present value of a simple ordinary perpetuity of 5,000 payable at the end of each quarter if the interest rate is 2% per quarter or 8% compounded quarterly. Kasi nga, diba, 2 times 4, 8%. Kasi nga, there are 4 quarters in every year. So, again, yung formula natin is PVSOP Actually, hindi ito yung formula natin eh. Okay, wait lang. Pero essentially ito. Essentially ito siya. But it can be translated into annuity payments, perpetuity payments pala. Sorry. Perpetuity payments over periodic interest. In other words, P is equal to I over R. Yung R mo lang dito is expressed as periodic interest. Okay? So, yung I or perpetuity payments mo would be 5,000 nga daw. And then yung R mo is 2% per quarter. So, again, do not forget to express yung interest mo in periodic. So, yung principal, yung ano mo, yung present value mo of ordinary perpetuity would simply be 5,000 divided by your periodic interest of 2%, 250,000. Ganun lang ka-simple yung perpetuity. Okay? Now, paano naman kung simple perpetuity due? By the way, guys, hindi ko na i-discuss yung ano ha. Paano naman, sir, kung I yung unknown, o paano, sir, kung R yung unknown. Very simple naman na yun. You have to, you have to simply manipulate the formula. 3 items na nga lang yung involved dito eh. Diba? So, for simple perpetuity due naman. So, yung simple perpetuity due mo is ito. So, PVSPD is simply, or the present value of simple perpetuity due is simply the present value of your simple ordinary perpetuity, or I over R, and then simply add another payment. So, I over I times I, or pag translate mo siya into like parang a compound formula talaga, so lalabas mo yung I, so I times 1 over R plus 1. Okay? So, especially pag ganito, no, pag si I yung unknown, or si payment, si annuity perpetuity payments yung unknown, mas madali mo i-manipulate yung formula pag nakaganto na siya. Kasi nga nakalabas na yung I. So, simpleng divide ka na lang dito. PVSPD over 1 over R plus 1. O kaya pag si R naman yung unknown, so mas madali pa rin to. So, PVSPD divided by I. So, times 1 over I is equal to 1 over R plus 1. So, lipat mo muna si 1 sa kabila. So, magiging PVSPD over I minus 1 is equal to I over R, tsaka mo siya i-cross multiply. So, magiging R is equal to 1 over PVSPD over I minus 1. So, manipulate yun yung formula. Okay? Try nyo din na kayo mismo yung mag-manipulate ng formula na hindi ko binibigay sa iyo dire-diretso ng madalian talaga yung formula. But I have already stated naman na kung paano nyo gagawin. So, anyhow, so, kung paano kung perpetuity due, so, again na, compute ka muna ng PVS, present value of simple ordinary perpetuity. So, 4,000 payable at the beginning of each month if the interest rate is 12% compounded monthly. So, payment mo, 4,000. Yung R mo would be 12%. 12% over 12 or 0.01. So, yung present value mo, yung SOP, present value of simple ordinary perpetuity is 4,000 divided by 0.01. You have 400,000. Tsaka yung additional payment mo na 4,000. So, yung entire present value of simple perpetuity due is 400,000 plus 4,000, 404,000. Ganun lang siya ka-simple. Nagiging complicated lang tong perpetuity problems, no? Pag in-include parang pag kinumbine mo siya with deferred annuity problems. So, alam kong wala to sa book nyo, but and hindi ko din sure kung existing ba to, but siguro naman oo. 'Di ba? So, this means na I kind of thought of this problem. I haven't seen anyone do this, but yeah, I kind of thought of this problem. So, I myself. So, ganun nga. So, asan na ba ako? So, for example nga, na may combination of deferred annuity yung perpetuity mo. So, for example, eto. Find the present value of a simple perpetuity of 5,000 payable at the end of each quarter if the interest rate is 2% per quarter or 8% compounded quarterly, and if the first payment occurs at 9 months from now. So, ito, since this is ordinary perpetuity, and then we're only talking about present value nga kasi walang future value sa perpetuity, our period of deferment here would be as if we are doing also the ordinary, what do you call this one? Ordinary annuity na deferred. So, period of deferment natin is length of the length of time before the first payment. So, that is 9 months, and then we deduct 1. So, period of deferment natin is 9 over 3 minus 1, that's 2. PVSOP natin is, again, payment. So, 5,000 divided by our I. So, that's 5,000 divided by 0.02, 250,000. And then, we simply have to use, again, our knowledge on equivalent values. So, since may dalawang quarters na parang, kasi nga, diba, yung 250,000 mo is the value of your money 6 months from today. So, magkano yung equivalent value niya today? So, you have to bring it backwards by 2 periods, which is your period of deferment. So, ayun, PVSOP mo, multiply mo lang ng 1 plus I raised to the power of negative D, you will have your present value of deferred simple ordinary perpetuity. So, that's 250,000. Multiply mo ng 1 plus I raised to the power of negative D, and you will get 240,292.20. For ano naman, no? For deferred simple perpetuity due, so, solve mo lang muna yung PV-SPD mo, tsaka mo siya i-bring backward. Okay? So, for example, in this problem, find the present value of a simple perpetuity of 4,000 payable at the beginning of each month if the interest rate is 12% compounded monthly and the first payment is made after the lapse of 1 year. So, in this case, since due yung problem natin, hindi na tayo magdideduct pa ng 1. So, yung buong D natin would be 1 year, o kaya, since monthly man tong compounding natin, no, o kaya 12 months. So, that's our period of deferment. Kaya, eto siya. 12. Okay, so 12 over 1. So, 12. Kasi 12 months in a 1 year, divided by 1 month per compounding period, so 12, o kaya naman 1 year times 12. Kasi nga, there are 12 months in a year, so 12. And then, so, again nga, di ba? We have to compute muna first for PVSOP. So, that's 4,000 divided by our compounding, our interest rate per period na 12% divided by 12. So, that's 0.01. So, that's 400,000. And then, you add the first payment of 4,000. So, the total PVSPD of our perpetuity due would be 404,000. And we don't stop there kasi nga may period of deferment. So, we have to bring it backwards by 12 months. So, eto naman, in this case, mag-iiba, hindi na siya parang may parang yung D mo sa due, tsaka yung D mo sa ordinary annuity, iba na talaga siya. It's no longer like, unlike dun sa deferred annuity due and deferred ordinary annuity na in some ways parang they are the same. But in this case, iba na siya kasi nga perpetuity due na yung pinag-uusapan natin. Perpetuity na yung pinag-uusapan natin. So, ayun, kasi nga yung 404,000 mo is yung present value mo talaga siya on year. Present value mo talaga to on year, ano nga yun? Present value mo talaga to on year, on year what? Parang 1 year from now. So, ayun. So, 404,000. So, yung 404,000 mo, you have to bring that backwards by 12 months. So, ayun, PVSPD mo, multiply mo lang ng 1 plus I raised to the power of negative D. So, parang nga siyang equivalent value formula mo. So, PVSPD mo is 404,000. Multiply mo lang ng 1 plus I raised to the power of negative 12, which is our negative D. So, ayun, you will get, magkano ba ito? 358,529.49. So, with that, now we're done discussing the entire chapter 6. I hope you have learned something for today. I will be posting also your assignment at parang at the same time, I'll be posting this video on your classes. And uh, the deadline for your assignment would be next meeting. And like not next meeting kasi I will give you na lang like until then. So dapat nakapag-submit na kayo before the start of the next meeting kasi nga when the next meeting will happen, your post test for this chapter will be given to you, and the deadline would probably be I will give you a few days from the day of posting, or maybe on the same day. I will just make it as an announcement when I will post your post test or your unit drill, your unit drill for this chapter. So again, no, reminding everybody that your do-it-yourself drill will be for this chapter will be will be posted the same day this video will be posted on your classroom. Deadline for it would be before the next meeting. And then by the next meeting, your unit drill for this unit will be posted. And I will give you siguro a few hours or few days extra to submit your post test. Okay? But your post test will be timed as usual, Kilgo. While you do it yourself, you'll have unlimited attempts until you get a perfect score or until the deadline will end, whichever comes first. Okay, so with that, I hope that you have learned something today. And if you have any questions, feel free to chat me personally or through our GC in our messenger. That's it for this video. Thank you so much for listening. Have a great day.